Hi EW7 online students. I'm going to make an informal presentation about some programming ideas, and we're going to focus on the mastermind homework assignment. This isn't explicitly a module, but hopefully it'll be useful for you as you work through that module assignment. Let me remind you what the mastermind game is. Player A picks 4 game pieces and arranges them in a row hidden behind a wall. This is what we'll call the code. There's color choices: yellow, orange, red, green, white, and blue. And there it is depicted hidden behind the wall with a choice of yellow, blue, red, blue. Player B guesses the code, putting 4 new pieces out. Here we've put out a white, yellow, green, green. And player A responds with 2 clues regarding the correctness of the guess. One is how many of the guesses are the right color and the right place. So in other words, the number of pieces in guess that match the code, meaning that the color and the location is correct. Then the other clue is the right color, wrong place. So of the remaining pieces, those that are not right color, right place, which are the ones that will still be needed because their color is correct to correctly match the clue. So in this case, none match up. That's the 0, right color, right place. That's none. However, the yellow is correct. This yellow will be needed over there. So that's what the 1 is for. Player B repeats now and makes a new guess. In this case, they have 1 in the right color, right place. This red is right color, right place. This red, and this green are not needed. 0. Next guess. The red is in the right color, wrong place. The yellow is in the right color, right place. And the blue is in the right color, wrong place. So 1 is good. 2 of them are useful, but in the wrong place. 1, 2. Here, 1 is correct. The oranges are incorrect. The red is correct, but in the wrong place. So it's 1, 1. And finally, we get the whole thing, and it's 4, 0. So we'd like to write some program to play this game. Oh, there's right color, right place, and the right color, wrong place. What we'd like to do is make a program where player A is the computer or Matlab, and player B is a person, for instance yourself or a friend, playing against the computer. Here's a text-based version of the game. Rather than use colors, we'll use the numbers 1 through 6. So the person enters a guess, 1, 2, 1, 3, 2, 5. The computer responds by telling it, repeating the guess, 1, 3, 2, 5, and then the number of right color, right place, right color, right place, right color, wrong place. A new guess, the computer prints out both guesses for summary and tells that in this new guess, no right color, right places, but 1 right color, wrong place, and so on. And finally, on the 4th guess, I believe we get it. It's correct. And the game is over. So that would be a text-based version of the game, and we'd like to write that for your homework. How would we do this in Matlab or any other programming language? And can we also write another function to be the guesser? So can you, player B, replace your intelligence with a smart program that does the guesses automatically? Let's think about the mastermind flowchart for the normal game. Here's a way in which you can think the program breaks down. The computer generates the secret code. Then it asks the user for a guess. It checks the validity of the guess. If the guess is not valid, it goes back and asks the user for a new guess. If the guess is valid, by valid I mean 4 integers, all between 1 and 6. Invalid is anything other than that. Valid doesn't mean correct. It just means, is it a valid guess? 4 integers between 1 and 6. Think about your conditionals homework. I think you already had a homework on that. If it is a valid guess, we will the computer computes the clue to return. In other words, the right color, right place, the right color, wrong place, using the real secret code and the guess. Then it increments a counter. Maybe the person is only allowed 10 guesses, updates the game display, and decides whether or not the game is over based on the counter, or did the person get the answer. If the game is not over, go back for a fresh guess. If it is over, display the appropriate message. That's called a flowchart. For once we start doing these kind of complicated programs, it's good to draw out a flowchart of how the logic proceeds. Let's think about how we obtain the user data, how we obtain a valid guess from a user. here's a little flowchart for that. This is coming in from some other program. Sorry, from some other part of the program. We're finally about to query the user for data. For instance, here, this is coming, we're either coming from the very first step or from the next step, from the previous step, and we're going to query the user for another guess. So that's what I mean by this arrow here. For some reason, the program has entered into this state. So one way to think of that flowchart is query the user for data. If the data is valid, move on to the next part of the program down here. If it's not valid, go back and ask again. We can do this a little differently. We can initialize the data to a known invalid value, then ask, is the data invalid? If it's not invalid, it must be valid. Then we exit and move on. If it is invalid, we can query the user for data and check if it's valid. Notice we've just switched around the order in which these two appear in the code. Here it was get the data, check if it's valid. Here it's check if it's invalid and get the data. To do this, we had to start with an invalid value to actually get into this loop. How many times will this loop be executed? Well, you don't know, because you don't know how many times the user is going to type invalid data. So therefore, if we don't know how many times the loop is going to be executed, it's usually a while loop. So here's a pseudocode for this. Initialize the data for what's on the right-hand side over here. Initialize the data to an invalid value while the data is not valid. Get data from user and go back. And keep checking. While it's not valid, ask again for the user to enter some data. It's nice to put a message in there. So if we insert a message here, we can see one approach to do this. Initialize the data to a known invalid value. If the data is invalid, if it's invalid, display a message and query the user for another entry and keep going through this loop. Every time they enter an invalid data, give them a message. Finally, at some point, they enter a valid data and you move out to the rest of the program flow. Here's the loop for this. Initialize data to an invalid value while maybe we have some program called isValid, which checks the validity of data. While that's not true, display a message of invalidity and get new data from the user and keep looping around until this is false. This being false means that the data is valid. There's a slight problem here, as this message will be displayed this first time through the loop. We initialize the data to a known invalid value. Is the data invalid? Yes, and we'll display a message even though that really isn't from the user. So what we need to do is make this slightly different. Let's initialize a variable that we'll define called askUser to be true. Then the loop goes in, it says, is askUser true? The first time it is true. So if it's true, query the user for data, see if it's valid. If it's not valid, display the helpful message and go back. If it is valid, set askUser to false and go back. Now on this time back, is askUser true? And the answer will be no, and you'll exit. So once the user sets up a valid piece of data, you'll follow this chain. Yes, askUser will be set to false. We'll go back up. Is askUser true? No, and we'll exit out here to continue. As long as the user keeps entering invalid data, they'll get a message and be asked to re-enter it, and we'll stay in this loop. This pseudocode looks like this. Set askUser to true while askUser. So while that is a true logical, get data from user. If it's not valid, display a helpful message. Otherwise, if it is valid, set askUser to false so that when we come back out of here, we automatically exit the while loop the next time around. This is an exact pseudocode of this picture. Great. So you should be able to start thinking about how you'll write this obtain guess from user. There it is, obtain data from user and return the function data. Return the data as a function. Now, how do we obtain input from a user? There's a program in Matlab called input, which allows input from the user's keyboard during program execution. It allows you to pause, the program pauses and asks the user to type something at the keyboard. So if I say this, user input equals input enter answer as a string, what ends up happening is when this command is executed, a prompt appears in the command window with the words enter answer, and it waits. Matlab waits until the user types an expression and presses return. the typed expression, whatever the user types, is evaluated in the caller's workspace, and it becomes a value, and that value is returned as the output argument of the function input. So in this case, it gets put into the value of what the user types is put into the variable user input inside the program, so inside our mastermind program. And the function or script resumes execution beyond this line. A second optional input argument to the input command makes it so that normally it says that the typed expression, whatever the user types, is evaluated. If you just want to take what the user types and get it back as a string, exactly the letters and numbers and characters that they type, then just use an S at the end. And that means don't evaluate what the user types, but just pass it back to me as a character string, and then my program, will figure out what to do. We'll probably do this way. With the evaluation is a little easier. So let's now think about this CreateResponse program, which you're writing in the function module. So remember that the guess and the code have to be combined to the final clues. In this case, the true code is 4615, and the guess is 1325. Notice that the 5 is right number, right place, and the 1 is right number, wrong place, and the 3 and the 2 are not. So this should return a 1 and a 1. Right color, right value, right place, right value, wrong place. So we have to write a program that does that takes a code and a guess and figures out these clues. So we need this function that determines player A's response to players B's guess and the secret code. It should be a function something like this. You pass it the code and the guess, and it returns the response. So for instance, the code is a 1x4, the guess is a 1x4, and the response is a 1x2. And it finally figures that out and passes it back as a 1x2 array. So right color, right place, the number of entries of code and guess that are exactly the same location, same color, same value. And right color, wrong place is the number of other entries in guess that will be needed because they're the right value or the right color to exactly match the code. They're just not in the right location at this point. So let's think of the pseudocode for this. So first what we'll do is we'll find the exact matches in code and guess, and the right color, right place equals the number of elements in exact match. Then you remove all the exact matches from both the code and the guess. Right? In this case, once I see that 5 matches up here and nothing else matches up, I want to get rid of the 5 and just focus on the 332 and the 463. I know that none of them match up, but there might be some values in guess that are in code, and I want to look through those. So what we'll do is we'll call these remaining things remain code and remain guess. Now what I'll initialize is the right color, wrong place value to 0. I haven't found any yet. And now I'll loop through each element in the remaining guess. That's this 332. And I'll see if it's an element of remain code. So is 3, let's start here. Is it in here? And the answer is yes, it is in there. It's right there. If it is an element, increase this by 1, so that changes from 0 to 1. And then delete that element from the remaining code. I've used up that 3. When I try to check this next 3, I don't want to also say that it's right because I've already said that this one was right. So I'll delete this 3, and then I move on to the next element in the remaining guess. So move to the next element, remaining guess, and that's what this loop is. So I'll just go through here, and what I'll find is I'll find 1. That one's right. This 3 won't match with a 4 or 6. The 2 won't match with a 4 or 6. And we'll get right color, wrong place is 1, as we'd expect. So that's some pseudocode. Should give you an idea of how to get started. What about AutoGuess? Well, if I had an array of guesses and an array of associated responses, I could figure out, as a player, I try to figure out what's my next guess. So how would an AutoGuess program work? So let's think about what's happened so far if the game was like this. I've made 2 guesses and I've been told 2 responses. Now what I want to do is try to figure out what's a new guess that's consistent with what information I know. So there's 1,296 possible codes, and I know 2 of them aren't right, these 2, but I know some information about those 2. This one has 1 in the right color, right place, and 1 right color, wrong place. This one only has 1, it's in right color but wrong place. So which other codes are consistent with this? Which codes are consistent with this? What could it possibly be? So let's think about it. Could the code be 5424? let's see if this matches up. Well, if the code was 5424 and I had made this guess, let's see, yes, the 2 matches, that matches, nothing else has a perfect match. So that's 1 right color, right place. And then this 5 is in the right, it's the right value, but it's the wrong place. So this, with this guess, would give me a 1-1. Let's check about what if this were the guess and that were the code. So 6362, 6362, nothing matches up, so it's 0 right color, right place, but the 2 is the right color, it's just in the wrong place. So indeed, this guess coupled with this code would also give this response. So based on this piece of information, it is possible that PC1 is the code. That is a legitimate code, and that's all I know. You can work through PC2 is still possible, because if that were the code, and these were the guesses, these would have been the responses. PC3 is still a possible code, because if that were the code and these were the guesses, these would have been the responses. PC4 is not possible. 1, 2, 3, 4. Notice that the 1 matches, it's 1 right color, right place, but then the 2 is correct, just wrong place. The 3 is correct, wrong place. So if this were the code and this guess, I would have been told 1, 2. Therefore, this cannot be the code. So what you can do is you can certainly cycle through all codes. If you had the right software, you could cycle through all possible codes. You don't know what the real code is. You can see, well, which codes would have given the same responses that I've been told by the player that I'm playing with. So here's an AutoGuess flowchart. You're given the game info. The game info is what the guesses were and what the responses were. You make a list of all the possible codes, and for each guess response pair in game info, each guess response pair, go through each code in the possible codes, start with all 1296, and call get response code and guess. If the answer from here matches the response that you matched, then that code is possible. If it doesn't match, the code is not possible, so remove the code from the possible codes list, making this list shorter. And then work your way around and go through all possible things. At the end of it, you'll have a list of all the codes that are consistent with what you've learned by now. If we back up 1 slide, you see that if you went through this, notice that these would not be pruned from the list. They would still be in the list, but PC4 would be removed from the possible codes list because it's not a possible code. It doesn't give the right, if it were the code, this would not be the right response to that guess. So think about that. And at the end of this, the possible codes only contains codes that are now consistent, with all the game info. So now here's a mastermind flowchart using a function handle for AutoGuess. So AutoGuess is player B, the guesser, and the computer is player A, the responder. And the flowchart represents the computer's actions, which calls instead of asking the user for input, it just calls the AutoGuess program for a guess. And then the game would look like that. Nothing even needs to be printed out, depending on how we display it. How do you debug your programs? When you write a function, there's almost always errors. There's 3 different types of errors. There's syntax errors. You've simply typed an illegal expression that has nothing to do with the values of the variables in the expression. Just parentheses are in the wrong place, not enough square brackets, something is illegal. The editor usually marks this line of code since Matlab can already tell it doesn't make sense. And Matlab will catch this if you run the function. And it'll give you an error statement. It may not even let you run the function. These are easy to fix. You just have made an undecipherable command. There's runtime errors. Those are logic errors that result in an illegal expression for specific values of the data. They're not illegal in and of themselves, but when the values are actually placed in there, it might end up being illegal. For instance, you might be trying to add a 3x1 vector to a 4x1 vector. Well, the sizes don't match up. But in terms of a plus sign, there is a plus operator. You can add vectors. But if the sizes are wrong, it won't work. So that's a runtime error. Matlab will catch that when you run the code. and Matlab will issue an error. And usually if you look at the error message, you can kind of figure out what's going on. You can even put some displays right before the error and see if you can what the variables are and try to understand what the problem is. Okay. There's logic errors, which are even harder, that result in the program completely executing but just giving answers that are incorrect. These, of course, are the hardest to fix because you really have to dig in. Your lines of code are all legitimate. They're just not correct. So how do you find runtime errors? The most primitive way to debug a program is to work out by hand what the intermediate values of variables should be for special cases or specific cases, and get rid of the trailing semicolons so that Matlab displays the intermediate results, and just call your function and compare the printouts to your hand calculations and try to see where things start to differ. That's a great way to get started, and you should start doing that. Once you figure out what's wrong, fix it, and then put all the semicolons back, and hopefully you're in good shape. There's also some debugging tools. Same thing, work out by hand what the intermediate value should be. Use the debugging tools. This avoids removing semicolons. It avoids changing the file. It allows you to stop the program in the middle of its execution and examine variables. I will make some videos on this soon, and you'll see how to do that. You can also check the MathWorks tutorials videos for how to use the debugging tools. That's what I'd like to say about this right now. I hope, I know I've been talking very quickly, but hopefully you've got some good ideas, and keep working at this program. I think you'll learn a lot, and this is a fun assignment that should empower you when should give you a lot of confidence when you're finally finished. Okay, good luck.